So guys, in this video we are going to see about the symbolic constants. These are not variables. I will show you the example. So let's say rows is equals to 5. So in programming language like Python, you can say this is the variable, but in assembly this is not a variable, this is a symbolic constant. The difference between a variable and the symbolic constant is this will not be stored in the data section or in the program's memory. Then why it is useful means we can use this value to assign value to a variable, or you can use that value in this code. Now I have the rows is equals to 5. Now I can say let's say temp byte rows. So now I can assign this standard value to this temp. So now temp points to the address containing the 5. So let's delete this now. So this is a constant and it will not be included in the executable. The assembler sees this rows as a constant which holds the value 5, and it will replaces this value of rows in any of your code with this 5. So on the assembling or the final output will be temp byte 5. So this will be the actual output. This assembler removes this symbolic constants and replaces every symbolic constant in our code with its value. In our case, rows is equals to 5. So this is about the symbolic constants. Now let's build our solution. Let's see if this rows exists in our memory or not. So okay, let's step over. Okay, let's open this memory window. Now we have hello world variable and a rows constant and a temp variable. Now I can say ampersand hello world. So you can see this is a string pointing to hello world. Okay, that's fine. Now let's try to fetch the value of rows. Ampersand rows. So it says unable to evaluate the expression because this is not there in our program's output, that is after in the program exe. So I hope you have understood this symbolic constants up to now. This is the basic concept. Actually we are not using the direct rows here. We are not creating a new variable. We are just pointing this rows as 5, and this assembler will replace this symbolic constants with their values when we compile. Okay, now what we can do is you can also say EQU. This is the Masm convention of this equating this symbolic constant to this 5. So now we can also build the solution. This is another way, and you can also say some text. Let's say hi. Now let's build the solution. So we have got some errors. We need to specify this brackets open less than and greater than. Now let's try to build the solution. Now it will be point to the high. So let's step over this. So now we know that there will be no rows. Let's say temp. So you can see the temp now have the values high. It's a string point, it's an address pointing to this high. Now if you type the rows, it won't be, because it's just a symbolic constant pointing to high, and it is gets replaced. The value of these symbolic constants are replaced in our code. So you can also evaluate the expressions here. So one thing I need to tell is that is dollar. So dollar points to the current address. So this hello world variable points to some address and it takes some bytes. The size of the bytes taken by this variable defined by each of these value. You can say h takes 1 byte, e takes 1 byte, and everything takes 1 byte. So in that way you can calculate the size by counting, but you want to automatically know the value of this hello world variable. Now what you can do is let me delete this. So I will create a new variable, let's say s size. So now I can say s size byte. Now instead of byte I can say equ, and let's say dollar. This is the current address. So this is the current address and minus hello world. So you can see this is the same syntax similar to the Linux assembly. We will have the address of this here, and we are going to separate the address of this hello world. So the exact offset will be the size of this hello world variable. Now you can also say equal to, or you can say byte. So let's just build our solution. So this size points to the size of this hello world variable. Okay, now what we can do is we can also say byte. So if you declare 10 variables, those 10 variables are stored in the contiguous memory. So after this variable ends, the next variable starts. So that's how you can say dollar minus hello world. So now what we're going to do is actually this will be stored in the 4 bytes, which is the D word. I'm just showing you that dollar corresponds to the current address. Build solution, and let's step over. And now if you open the memory window, so we can see let's say ampersand hello world. So you can see the hello world string here, hello world, and what we can do is we can say ampersand s size. So you can see here address, the address of this variable is 009f500d, and the value is also you need to count in the reverse byte order, 009f50 and sorry, where is this 0d? Okay, it stores this actual address. So what we can do is this address minus corresponding this hello world starting address gives you the length of this string. So now what we are going to do is we are going to set dollar current variable address minus previous variable address. Note that this method only works if these two variables are defined one after the other. So if you defined after 2 or 3 variables, it won't work because these two will be allocated in the continuous memory. So now let's step over. Now let's open the memory window, and let's say ampersand s size. Now you can see the size of this the content of this s size variable is 0d. That means a is 10, b c d 13. So the length of this string is 13. 1 2 3 4 5 6 7 8 9 10 11 12 13. So you can see the content, the size of this string has been stored in this s size variable. That's how you find the size of a string using this dollar minus hello world, means the previous variable's address. So you can also point that to eq, and there is another macro, that is text eq. So this will point only to the string. So this is an example. So you can also assign this size to some other variable and it will point to this string. uh, so, so I will just define another thing, rows 5, and you can also evaluate the expressions in this text EQ. To do that, you need to say percentage and we need to say rows plus 1. So now size stores the value 6 because we are adding the 5 plus 1 and it will be evaluated as an expression. Let's build the solution. So you can assign this size variable size symbolic constant to any other variable. So that's all for this video, symbolic constants. These are very helpful for evaluating expressions, to store the strings and also to find the length of the variables.